Hello everyone, welcome back to my channel. Today I'm going to be solving this exercise, which is pretty simple, but I wanted to record a video just for the sake of documenting what I'm doing. This is pretty straightforward. We are given a number, an integer number, and we need to reverse it, and it has to work for negative numbers as well. And we have to consider the boundaries of it, which is we need to work for 32-bit signed integers. Okay, let me do the happy path first. Yeah, and I'm going to do it in C++. Okay, this is the happy path for it. 1 to 3 is being reversed to 3 to 1. Let's see if it works for negative numbers. And yes, it does. So the tricky part will be, what if we send a number that would result in a non-integer number like this. This is a valid integer number, right? So let's see what happens. And we get a minus negative number, which makes no sense, and we can be sure that this is the wrong value, right? Okay, we need to prevent that, but let's see what's happening there. Let me clean up this. Okay, let's take a look on it. Let me set up a breakpoint into the while, and let's run this. Okay, so we need to understand that as part of this while loop and iteration, we're getting the last digit from the original number, and we are creating a slot into the reverse variable. We are creating a slot by multiplying that by 10, and then we finally adding that digit into it. So that way we are iterating a lot of times, and we are generating the reverse version of the original integer, right? So we need to understand this line. This line is the one that's where the integer is going to be overflowed. Okay. But at this first case, it's going to be all zero, so let's skip it. Okay, now we're in the second iteration, in which we are trying to calculate digit, which is, we will just hit next. Okay, this is the line that it's more important for us to understand why we are getting that negative number. So first, let's understand the happy path for it. Okay, ref, which is the reverse value, right? Okay, this is the line, which the assembly line called for that. We're just taking this value from this direction, so we can just see what's that. Let's print that out. It's RBP -8, and that is 7, right, which is the reverse value, right? So we're still in this line, okay? So that 7 is being put into the EDX, okay? And EDX is being assigned to EAX. So EDX and EAX have 7 so far. And we are doing then into EAX a bitwise operation where we're shifting to the left 2 bytes, which means 28. So EAX 28, okay, and EDX 7, okay. So we are adding EDX to EAX, which means plus 7, 35. And then we are doing that EAX is going to be added to EAX, which means 35, 35, 70, right? So this is the number that we are expecting, right? So we're in the second iteration, rev is 7, and if we want to put the 4 digit into it, this has to be 70, right? So if we just go next, that's it. Rev is 70, and now the next instruction will be to put the digit 4 into 70, which is going to be 74. So that's the happy part. That's how the multiply by 10 is done. Let's skip this up to the last digit where the overflow is going to happen. Okay, we are here. We take the last digit. The last one is 2. So this is the actual value of the reverse variable, which is a valid integer number. Now we're in this line. We're about to create the slot for the next number, right? By multiplying this by 10. If we do that, then this number is not going to be an integer anymore, right? That's what's going to happen here, but let's calculate that by ourselves. Let's go here. So what's in this direction, which is reverse, is going to be put into EDX. Okay, now EDX is going to be put into EAX. Okay, so EDX and EAX up to this point are this number, right? Now EAX is going to be shifted to the left 2 bytes, which means this. Okay, now to the EAX, EDX has to be added, so this value. Okay, now we have this result. Now EAX has to be added to EAX, which means this plus this. So this is the result. This is the result, right? We can see the 0 here. So if we add the 2 to it, we will end up having this reversed value of the original integer. But this is actually not a valid integer. So this instruction is going to be overflowed. Okay. So let's just hit next and let's see what happens. And boom, you see here, rev is a negative number. So let's ask us why this is happening. Okay, let's print this out, the hexadecimal value of that variable. Okay, let's print the hexadecimal value of rev. No. No, I'm doing it wrong. Print the hexadecimal value of rev. Okay, this is the hexadecimal value. Okay, and this is the value, and what it was supposed to be is this number, right? Let's convert this to hexadecimal. This is the value that we were supposed to have, but not. We didn't, right? Instead we got this hexadecimal value. So if you realize, this is 1, 2, 3, 4 bytes what we got from here, which is okay because it's a dword PTR, meaning a 32 bytes data type. But we wanted to have, as per our calculations is 1, 2, 3, 4 and half a byte, meaning 4 bytes plus 4 bits, this one. So this one is missing. If we compare this and these are basically the same except by this one. So the difference between those are 4 bits, which are basically lost. We don't know where they are, right? So given that this is the value, let's see, but this is basically being converted by C to the 2 complements, right? To the 2 complements. So we can just take the binary part of that number, and we can see that the most significant number of it, the 1, is the sign. So when we want to calculate the sign of an integer number via the 2 complements strategy, this first digit is the sign of the integer, meaning that 1 is for negative numbers and 0 for positive numbers. We see here is 1, which means the number is going to be negative, like it's in our case, right? That's it though. That's it. Then we can calculate what's going to be the 2 complement of it. So in order to calculate the 2 complement of it, we can just do this. Rotate this by 31 digits, which is what we have here, and we got this number, right? So this is the number we got here. So it's this number. What is we're getting from the execution of the application is just the 2 complements of the number, and obviously there are 4 bits missing here because that we wanted to put a big number into a 32 data type structure, right? So that's it. Okay. So what can we do next here in order to prevent that? We can just pre-calculate that like we did before and say that if it's about to overflow the structure, then just return 0, because here is that what it's saying. If it overflows the integer, then just return 0. Then let's do that. Right now it is returning this negative number, and we want I will use constants for it. Okay, I will say if ref is major than int max, removing the last digit, or it might happen that it's the same but the next number will be bigger. Let's say if it's equal, then the maximum except the last digit, and if digits to be added next is major than 7, then we have to return 0. Have to do the same for the other case, which is minor to, if it's minor, or if it's the same but the digit to be added is -9, because this is it. This is the minimum value, right? But if this 8 becomes 9, then we are in a integer overflow situation. If that's the case, it's 0. Okay, that's it. Let's test this out. Okay, it's working. Yeah, it's working. Let's send this out. Oh, it's failing for this number. Expected. Okay, let's see what's happening. Okay. This is wrong. I forgot this. Okay, that's it. Let's try now Python. Okay, I will do the happy path first. Okay, this is but the thing here is that it's not going to work for negative numbers. It just crashed. The way the whole modulus is calculated here by Python is not like C. Okay, that's what I had to handle a single a part of it. Okay, the thing in Python is that everything is integer for everyone, but underneath it's a long value. It's a long C that structure. But I think that's different with Python 2. So let's say here if what's the type of this? It's an integer. And what about 64? Integer. 128 integer. But Python 2 was different. It was 32 bytes integer, 46. No, 46 is long, right? This will be the limit, 62. But for Python 3, everything is an integer, even though underneath it's not. But for the user landscape, it's everything integer. So there is no sense to limit here the 32-bit operation, because that's going to be automatically handled by Python. So the same case as the C++, if we send this integer, it's not going to be overflowed, it's going to be handled automatically by Python. Okay, so what can we do here is just calculate what's the zebras number, and here say if that zebras number is it's actually in the boundaries of the 32 bits size, then return 0. Okay. Okay, 0. What if we send this negative number? 0. Okay, that's it. Okay, let's try now JavaScript, which is basically going to happen a similar thing that Python. Okay. Okay. Okay, now it's working for negative numbers. So the thing here is similar than Python. JavaScript is going to handle the integer data type for us. I think it's going to be the 553 double precision data type. So we have to calculate here. It's rev. it's working. Okay, now Golang. The happy path's working. Let's try the negative numbers. Yeah, it's working. So in Golang there is support for different size of integers. We do have the integer 32, which will allow us to do the same we did with C++, which before of doing this calculation we can just see if it's about to overflow the integer or not. But the thing is that here in the exercise we have to use integer. An integer like this in Golang you can see this is at least 32 bits. So as far as I know, the integer value data type in Golang does the calculation based on what kind of machine you have. So it will adapt. So basically Golang is going to handle that for you. It's going to automatically set up the data structure for it. So all we have to do here is the same we did with Python and JavaScript. Let's test this out. 0. Okay, it's working. Okay, it worked. Wow. So I hope you enjoyed the video. It was interesting for me to see how this integer and the data structure types works in different languages. I hope we can see more videos in the next time. See you. Bye bye.